morning. Welcome to the USJI week panel discussion on the introduction for craniofacial translational research based on molecular craniofacial development research. I'm Kazuichi Uchida, president of US Japan Research Institute and also the vice president of Waseda Universities. And USJI was established in March 2009 in order to dispatch policy-related research results of the faculty members of participating universities. At the beginnings, there were 5 universities. But from this April, Dosha University, Kyushu Universities, and Tsukuba University have joined. And we are financially supported by the business society both in Japan and the United States. The mission of USJI are to formulate public policy, to encourage research on global issues, both the US and Japan face, and to link Japanese researchers to the United States and other countries. We have concluded the USJI week twice a year, in March and September, and have shown Japanese point of view on current economic, political, and social issues to a wider audience in the United States. With regard to the topics of seminar, we have discussed such topics as national securities, economic collaboration, financial crisis, future of higher education, development of alternative energy, and sustainable environment, and so on. Today, we are very fortunate to welcome Professor Takahashi of Kyushu University, the first speaker from Kyushu University. Also, this is the first time for us to include research on dental health. And Professor Takahashi will lead the panels of this interesting topic. As myself is a lawyer specialized in Japanese civil law, so this is a quite rare opportunity. And so I'm very pleased to be able to listen to the research results of oral health research. I would like to welcome Professor Takahashi.
Thank you very much for introducing me, Professor Chida. I'm the leader of this project, and actually I'd like to give you some opening remark this morning. Actually, craniofacial research is the very important field of the dental health. And actually, today we are going to present some. Maybe I asked this right. We will introduce our research to the here your audiences. And can I have the first slide, please? Second, sorry. So next, please. Actually, the what we are talking about now, what we are researching about is the things about the craniofacial anomaly. As seen in the background, we have some craniofacial or oral anomaly patients. 1 out of the 500 to 700 live births. And those kind of patients have the dysfunction with the physiological function and also the psychosocial function. In the dental field or medical field, we are thinking about treating the chewing, breathing, and swallowing. And at the same time, sorry, I'm using this, my one. And at the same time, they have the speech problems because of the this kind of the anomaly, and they have the communication problems. And actually, when once the patients get the this kind of the problems, we have to treat the patient during their growing from the newborn to the adulthood. So we have a lot of programs, and we have to develop a lot of things by the craniofacial developmental molecular biology or something like that. You have to treat. And first, I'd like to introduce you that the risk of the craniofacial anomalies. Based on the WHO data set investigated between the 1993 to 97, cleft lips and palate risk for the cleft lips and palate is about 1,000 by 1 out of 1,000 in the US, Atlanta, and maybe the 850 in 1 out of 850 in Canada, and 600 1 out of 600 in Japan, and so on. And actually, not only the cleft lip and palate, we have a lot of different type of syndromes, like having a craniofacial anomaly, and also the limb, hand or foot anomalies, like APAC syndrome, Cruzon syndrome, or any other. And actually, we have this kind of a patient every day in our clinics. So, can I have the next slide, please? Therefore, what we are looking at in our clinics or in our laboratories, we have to know, we want to know the mechanisms of craniofacial development to clarify the cause of those diseases, and also develop a regenerative medicine or dentistry using stem cells, or and also this is somewhat different issues, but present a need of worldwide collaboration to provide current therapy to all over the world. Because actually in US or Japan, we are very developed, and we can give the good treatment to the patients. But in developing countries like Asian countries or African countries, they don't have enough. And actually, some of the oral surgeons visit to give them the oral surgery, but actually, even once they get surgical treatment by the development of the jaw bones in the craniofacial region, or the tooth eruptions are affected by that kind of the problems, and actually, patient needs very long-term treatment from the newborn to the adulthood. So this project actually, what we are looking at in this project is the molecular biological things, craniofacial biology, and also the provision of the treatment to the patient who cannot get that kind of treatment so far. So today, can I have the next slide, please? Today, Professor Nonaka and Dr. Liren Sham will give us the part of the craniofacial anomaly and the research-related talk, and we have a panel discussion about the craniofacial researches and beyond. Panel discussion for the craniofacial researches. And actually, after that, future of the research project for the regenerative dentistry by the Dr. Yamaza. I took too many minutes, sorry. Actually, we'd like to start along this program, and actually we will have the keynote lecture from Professor Kazaki Nonaka, who is the professor and chairman of the section of pediatric dentistry, Kyushu University. And after that, we have a lecture from Dr. William Sham, and have a panel discussion and the presentation from Dr. Yamaza. Then can I have the lecture from the Professor Nonaka? Could you start your presentation?
Thank you, Bob. I'm Kazu Nonaka from Kyushu University. I belong to the section of the pediatric dentistry. And my title of my talk is Craniofacial Anomaly and Translational Research, focusing on gene and maternal effect on cleft and palate in human as well as a mouse model. Actually, three of us, Bob and Har and me, spent a couple of years at NIH, Bethesda. At that time, Dr. Liang Sham was our teacher in the research. And here is Dr. Harold Sladkin. He's our American father. And Dr. Oishi, he's a medical doctor and a dentist and oral surgeon. He's our Japanese father in academic area. We are from the southern part of Japan, and we are work at the Kyushu University Hospital. And then there is a hospital is in the root trees. So we are a kind of a dentist for the children in the trees, and take care of the patient with a mother. That is our policy. I'm a pediatric dentist and a family dentist who are very kind to the child as well as the patient, as well as the mother and the father. And also our research aspect as well as the educational aspect on the focus on the gene and maternal effect on growth and development of the child. We have a very nice textbook called Gorlin syndromes of the neck and of the head and neck, which contains thousands of craniofacial anomalies. And also, we can access to the NIH website to get the most current information about the craniofacial anomaly every day. We have a lot of patients who are affected with craniofacial anomaly. So today I just pick up one of them. Child who are affected with the Treacher-Collins syndrome, which is caused by underdevelopment of first branchial arch. Some of you are very familiar with the meaning of first branchial arch, but some of them are not so familiar with it. Very sorry about that. He had some difficulty to swallow or breathe because deformity of oral cavity or narrowed pharyngeal space, which induce difficulty for breathing. So we perform the dental treatment under the general anesthesia, which is essential for this kind of patient. Also for the congenital anomaly, online Mendelian inheritance in man, we call it the website OMI, is quite useful and powerful. I will pick up the, this time I will pick up the left lip and palate as one of the congenital anomalies. The etiology of the facial cleft is not so easy because it's a kind of the multifactorial congenital anomaly disease. So one is a gene, genotype, and the environmental effect, like air pollution or water pollution, sometimes change of the climate, and also maternal uterine effect, which supplies a developmental space for the fetus development. sometimes maternal nudging will contribute to the occurrence of cleft lip and palate. Improvement of early diagnosis using the ultrasonic survey enable for us to identify exactly the cleft lip in fetal stage, like this. By using the ultrasonic survey, medical doctor easily find out whether or not it does have some facial cleft like that. So they call us when they found the presence of cleft lip and palate. Then we visit at the instant when newborn baby is delivered. At that time, we are also supposed parents who are suffer from the mentally because she had a affected baby, so she's struggling. So we have to also help and then explain how we can manage the patient children from the beginning to the until the adult stage, which Bob explained already. For this congenital anomaly, fusion of nasal process and maxillary process is a very essential at the stage of the 7 or 8 weeks of gestational stage. Incomplete fusion induce cleft lip like this. So epithelial cell, which is a kind of a coat covered with each process. Epithelial cell plate is very hot spot for researcher to understand the etiology of molecular etiology of the cleft lip and palate. As a clinical dentist for children, we took the impression of the upper jaw to make some denture for the newborn baby, like this. We prepare the plaster, then dental technician manufacture the plate like this. It's a first treatment for the children affected with the cleft lip and palate. Cleft lip and palate is one of the neuropathy which is due to the abnormal self-fate of cranial neural crest cell. And the occurrence rate already Bob explained, approximately 1 over 700 newborn baby. So wearing the hot plate help the smoothly sucking of milk and the swallowing and breathing. Smooth swallowing and breathing prevent pulmonary infection at those times. Without the hot plate, sometimes they have a malfunction of tongue movement like this also. Additionally, recently we performed nasio-alveolar molding therapy. NAM means hot plate plus nasal stand like this. This numb therapy helped to form the normal nasal wing just after the operation. I will explain the operation later, like this. Around the 6 months, at the 6 months, oral surgeon performed the surgical operation of the cleft lip to connect the cleft lip prominence through the suturing or suturing the both prominence, like this. We have a very wonderful oral surgeon. His name is Dr. Masaki Sasami. He's a wonderful one of the top oral surgeon in Japan. I hope in the world also. However, cleft of primary palate, which have some difficulty because in this case, patient have a bone defect at the upper jaw. This bone defect disturbs the tooth eruption. So we have to take care of the children as a team of pediatric dentist and also dentist as well as an oral surgeon. We have to take care of the children as a team. How can I do that? I will explain. Around 5 years old, all of teeth are milky teeth. At that time, pediatric dentist try to prevent the dental caries. Once milky tooth is lost due to the severe dental caries, which means that you lose alveolar bone, which are part of the jawbone, which make the problem more severe. And then around 7 years old, anterior part is a permanent tooth, and the posterior part is still a milky tooth. We call it a mixed dentition. At that time, orthodontists like Professor Takahashi take care of the tooth alignment, just anterior part to guide the normal occlusion. Then final stage, around 17 years old or 18 years old, almost a teenager. Medical doctor surgically isolates a piece of the front bone from the groin, like this. He isolates a piece of the bone, which will be grafted into the cleft region of upper jaw, like this. This procedure regenerates a new bone at the cleft area. Then finally, prosthodontist like Professor Ichiro Takahashi, complete tooth alignment. Tightening. This is our approach as a team. Here is newborn is degenerate. Then he can move the permanent tooth to the newborn area, newly formed bone area. I'm talking about translational research. From now, we have a very nice mice model. Here is a mice which have a very similar symptom like a human affected with a vertical palate. Spontaneous incident rate of cleft lip and palate in these mice is around 25%. From mice to human, from human to mice, we have to interact with each other. Actually, I apply this technique to understand the maternal environmental effect on the incidence of cleft lip and palate. This is a surgical transfer technique. We collected the embryo from the mice, then we transfer this fertilized egg into a pseudo-pregnant mice by using a microcapillary under the microscope. Then 2 weeks later, mother delivers a newborn baby, which is developed from the transferred fertilized egg. Here is a top is the experimental design, bottom is a result, a part of result. We collected the embryo from the CL laser, then transfer into the 2 strain of the pseudo-pregnant mice, mother. One is the same strain of CL laser, the other is the C57 layer, which are resistant to this disease. Then when we compare the incident rate of the cleft lip and palate in newborn baby, which is originally derived from the transferred egg of CL laser mice. This strain in the C57 bear mother could induce the occurrence rate of CLP in comparison to the CL laser mice, which means that maternal uterine condition have some important role to prevent cleft lip and palate or enhance the occurrence of cleft lip and palate. Even though it's a mice model, we can identify this kind of result. Also, we performed fetal surgery in this mice model. When we perform this fetal surgery on the mice who is affected with cleft lip and palate, operated side is reconnected like this smoothly without any scar formation. But unoperated left side is still clefting. I lost one figure to explain the detail of the study. Very sorry this time. From the standing point of genetics, we are collaborating with Dr. Scott Rodanoff at the Medical School of Hawaii University, Honolulu. Also, from the standing point of the environmental effect of mother, we are collaborating with Dr. Frank Wagner, Nijmegen, Netherlands, in European country. Now we found some molecule which is expressed in the patient epithelium of the maxillary prominent as well as nasal prominent like this. If this molecule is something wrong, which induces a collecting like a photon. I explained some very important technique which I learned from Dr. Lilian Sharma at NIH. Collected whole embryo, we can culture for 72 hours in the bottle with a very precise medium. During this time, we can deliver some protein or gene which will be rescue the anomaly of craniofacial, which can rescue the craniofacial anomaly partially. Also, organ culture system is a very useful technique to understand the function of protein or gene which is delivered in the medium. Last part, please pay attention to the milky tooth, baby tooth. You can easily find the milky tooth, which will be exchanged with the permanent tooth. This is a very wonderful treasure for the human being. I always thinking about the meaning of the milky tooth more than 20 years as a clinical pediatric dentist. We can isolate stem cell from the exfoliated milky tooth, which contain the very wonderful fresh tissue. Then we can collect the cell. Stem cell from human exfoliated residual tooth, we call it shed, which have a capacity of high proliferation and multipotency, and as I shown, easy access without any surgical operation, which is a promising source for cell-based regenerative therapy. Haru will present more detail about the possibility of cell for the regenerative medicine. My time is almost expires. Here is my friends in the world. Every 2 years, we attend the Gordon Research Conference section of the craniofacial morphogenesis and tissue regeneration. They give us a very important advice and information for us. And here is my wonderful colleague, even though it's a very small team. And here is my family. Father and mother, they are more than 80 years old, and almost they are kind of dementia. So we hope we try to help them, not only children but also scientists. Thank you very much for your kind presence as well as attention. Again, thank you very much.
Thank you very much. Time's nearly running, so I'd like to introduce next speaker, Dr. Lilian Sham from National Institute of Health. She's the chief of the Integrated Biology and Infectious Disease branch in NID, National Institute of Dental and Craniofacial Research. Could you please start your presentation?
Thank you. Good morning, everyone. First and foremost, I would like to thank President of USJI, Professor Ishida, for inviting me to participate in this event, and of course for Professor Nonaka and Professor Takahashi to organize this event. And it's a pleasure to meet Dr. Yamasa for the first time. So I'm Lilian Shum with the National Institute of Dental and Craniofacial Research, which is part of the National Institute of Health, we call NIH. I did not bring my business cards with me, so this is my phone number and email address if you want to get in touch. So the National Institutes of Health, or NIH, is the nation's primary support of medical research in this country. The mission of the NIH is to turn discovery into health, a process that we call translational research, and so it is very timely for us to talk about craniofacial translational research in this particular event. The funding at the federal level for NIH is $30.9 billion in FY fiscal year 2012. The majority of this funding, 80% of this funding, went to support 50,000 competitive grants to 300,000 or more than 300,000 researchers around the country as well as around the world. In fact, there are a few Japanese researchers currently supported by the NIH, for example, in clinical research, clinical trials, and specific genetic study. This is our website, www.nih.gov. Please feel free to visit our website to learn more about the funding opportunities, research at the NIH, research supported by the NIH, and then the institutes comprising the NIH. So, as I say, the National Institute of Health is one of 27 institutes supported by the NIH. We support research in a broad variety of diseases and conditions affecting the craniofacial region, including orofacial pain, temperamental joint, caries, periodontal diseases, oral cancer, biomaterials, dental materials, salivary gland tumors, and of course bones and teeth. So in our website, you can also learn a little bit more about the research that we support from this institute. Now, what I would like to focus my talk on today is our support for a national resource called the Faith-Based Consortium. So this slide shows you the inception of this consortium. The first time we solicited for grant applications was in October of 2008. But before 2008, we had a number of discussions and workshops and seed money provided for some researchers to get ready to form this consortium. So in October, we issued a solicitation we called Request for Applications. We received a pretty healthy number of applications, and the NIDCR set aside $6 million to support the formation of this consortium. It May of 2009, we received the grant applications, and they were reviewed by a panel of experts, both scientific and technical experts. In September of 2009, the consortium was launched with 11 projects, and I'll get into a little bit more details of these projects. The small difference in managing the consortium as compared with providing grant money in support of research is that NIDCR staff member, including myself, we partner with the investigators in these projects to manage the day-to-day operations in terms of looking at future directions, next steps, how best to coordinate, how best to collaborate. In November of 2009, we had an inaugural meeting in Bethesda. At that time, we invited the investigators from all 11 projects to meet, to get to know each other, get to know each other's project, and preliminarily find points of connections and points of collaboration to make the consortium larger than the sum of just 11 projects. We were there to identify synergies and collaborative ideas. And then every year from 2010 to 2012, we have an annual meeting. The first meeting was in Pittsburgh, Pennsylvania, the second meeting in Denver, Colorado, and the third meeting in Los Angeles, California. In this meeting, the 11 projects, investigators from the 11 projects who presented their work from the past year. We also have a panel of experts, we call the scientific leadership group, to provide us with an assessment of how the progress was going during the past year, and also recommendations for a path forward for the next year. So it's sort of part of a brainstorming session and part a progress review type of meeting. Now, very timely in September of 2012, which is this month, we are planning on continuing our support for the Face-Based Consortium. So this launch of the Face-Based Consortium was intended for a 5-year project. We have seen tremendous progress in the last 3.5–4 years, and so the intention is to continue support for this Face-Based Consortium. And in about a week, we will present this idea to the NIDCR Advisory Council for them to make recommendations as to the form and shape and the amount of set-aside funds to continue with what we call Face-Based 2. So a little bit more about the consortium. That was the historical recap of how the consortium came up to be. The intent of the consortium are threefold, shown here. The first objective is to collect systematically biological information that instructs craniofacial development. We have invested in a number of projects that are basically data production center, and I'll show you a few of those in the next slide. We intend to collect a large volume of data, high throughput, comprehensive amount of data that relates to craniofacial development of different kinds. The second objective is obviously to make this information available. So after we've collected the data, we want to be able to integrate this data and make the data available to the research community at large, not only in the United States, but around the world. And the third objective is to allow the data to show points of connection so that other researchers can come, download the data, clean up the data, and generate new hypotheses and test those hypotheses in the laboratory. The website is www.facebase.org, and I'll show you a couple of screenshots later on. The structure of the consortium, in order to support the three objectives, follows what we call a hub and spoke model, very similar to a wheel, and I'll show you that in the next slide. The first 5 years is focused on mid-phase development and orofacial clefting, some of the pictures you've seen from Professor Nonaka's slide. The reason for that is we felt the community studying craniofacial development is large, but the strength of our community reside quite well in research and mid-phase development oral facial clefting, and we want the consortium to have that critical mass, to have that successful launch, and that's why we're focusing at the first phase on mid-phase development, and I'll get to a little bit more of a glimpse of the second phase. So this is what we call a hub and spoke model, so very much a wheel. The hub, the center hub, is led by Dr. Marazita and Dr. Jeff Murray from the University of Pittsburgh and University of Iowa. This is entirely a data coordination and management hub, meaning that researchers will funnel data into an informatics hub, and they will curate the data and put it up on the web and make this information available. There's a lot of IT infrastructure that was developed in support of data management, because these are very large data sets. Shown here also are green connections. These are projects utilizing animal models, and you've heard from Professor Nonaka's how useful animal models could be. We also have red connections to projects focusing on human subject research. We have a number of green circle projects focusing on producing the data that relates to craniofacial development, and a couple of yellow circle projects focusing on technology development. So, for example, we support the work of Dr. Chai at the University of Southern California. So his project is focusing on the functional genomics and the use of rescue models. What that means is that there are two parts to his project. Functional genomics is to collect comprehensively all the genetic information that relates to craniofacial development and to identify the functions that are related to each individual genes. He also had developed a number of mouse models, but not only to develop the models to mimic the human conditions, but to use the mouse models to see if there are proof of concept rescue approaches in these models. The premise is that if we can develop rescue and preventive measures in animal models, we might be able to translate the findings into human patients. As you see, there are a variety of different projects. We have genetics, we have transcription, we have proteins, we have 3D analysis in humans as well as in animals. And then the development of tools. For example, we support the work at Jackson Laboratory to develop a series of crelines, meaning that these animals are ready for researchers to use in different breeding backgrounds to create clefting of different kinds to further mimic the human conditions. And these, at this point, are researchers around the country, East Coast, West Coast, and in the Midwest. At this point, we do not have any institutions outside the United States. So this is our homepage, just a screenshot of what it looks like. Again, it's www.facebase.org. We have data there for investigators to download and to look at. You can register with the website. The data is downloadable without cost. It's free for you to look at a complete data set or partial data sets. We have a collaboration with the fish face, which is an atlas of zebrafish development, because zebrafish is also an animal model, not only mice and rats are animal models. We have normative data, database of normal facial development for different age groups for Caucasians as well as African Americans. Here are a couple more screenshots. We have a collection of scanning electron microscopy of mouse facial development, both frontal views and side views, with color-coded of the different regions. So for example, Professor Nanaka spoke about the first branchial arch, which is coded in pink in a series of pictures, and then you can follow the development of the arch earlier on from two bilateral pieces into a single piece, the lower jawbone. We have posted some posters that were presented at the 3 previous annual meetings, and so please feel free to browse through those posters. Not all posters were posted, but the ones there, I think they should be of sufficient resolution to look through the content to see the progress over the years. A few more here. This is a list of animal models available from Jackson Laboratory. They are also available for dissemination. Animal models are only, they are available and they only charge minimum shipping and handling for breeding pairs. This is a list, a sample of some of the data sets that's currently available. We have a timeline for investigators to continue to deposit data regularly, and so please sign up for the website and check on the data sets once in a while. So as I alluded to at the beginning, we are committed to continue our support for FaceSpace. We hope that it will continue to be successful. So the next phase is we call FaceSpace 2, short of a different name. We would like to extend our support for functional genomics of craniofacial development and disease beyond mid-face development and beyond oral facial clefting. As you know, there are a number of craniofacial diseases and conditions, for example, Trichotillman syndrome that Professor Nanaka had touched upon, as well as other type of data sets that are currently not available in FaceSpace 1, for example, proteomics or epigenetic regulations. Those are very important data sets that we would like to capture in the next iteration of FaceSpace 2. So that's my last slide. Happy to answer any questions when we have a panel discussion, and thank you very much.
Thank you very much, Leah. So we'd like to start the panel discussion, but actually the time is slightly running. So this time I would like to talk about the setting up the consortium between including Japan and the United States or something like that, and whether we have a possibility to set up that kind of thing or not. So Leon, do you think that the National Institutes of Health can fund the Japanese Institute or Japanese university to be involved in the FaceSpace 2 or something like that?
It is very important for FaceSpace to grow beyond domestic institution, meaning United States institution, and we welcome international collaborations, and FaceSpace 2 is a real chance to do that. There are a number of ways to collaborate. First of all, without even going into FaceSpace 2, data sets from around the world, comprehensive data sets from around the world are welcome for incorporation in current FaceSpace. So if you have a data set that you have profiled a particular mouse model, you can contact FaceSpace and offer to donate the data set to be incorporated in that too. The next iteration of FaceSpace 2, it would be an open competition, and so our researcher, either primarily from an international site or in collaboration with the United States investigator, are welcome to compete for funding for FaceSpace 2. The topic is up to the investigator to come up with, depending on their strength and what areas they want to be. It is important for any international collaboration to articulate very clearly how the research would be done in an international site compared to a and how the coordination would be, because it might be a challenge because of geographical distance. But we've had supported international sites in the past, and we hope to be able to continue to do that in the future.
Right. Thank you very much. How do you think about how do you think about the be involved in that kind of project in our from Kyushu University or our collaborators?
International collaboration is very essential for not only for us but also the younger generation. And so for this purpose, Kyushu University Dental School, we are right now applied to establish a new center for the dental and the craniofacial advanced research center to the government. So which we also very helpful to collaborate from our side. Yes.
Actually, this is a USJI events, and actually I think we need to want to talk about the collaboration between the United States and Japan, and actually our Kyushu University Dental School, Dental Hospital is trying to establish a new craniofacial center, including clinical research and also translational research. So if we could have that chance to work with the face-based, it would be very helpful and also good for us. Good for us. So. I think that today in the lectures or presentations we talk about a lot of translational basic researches, but actually how we can connect these kind of translational research or results of the research to the actual clinical situations. Actually, as I told you earlier, it is still in the developing countries we don't have enough medications there. So can we involve that kind of the issues in the face? Actually, it may be difficult, but the face-based or those kind of consortia. How do you think about that?
So the intent of the face-based consortium is to support research, is to translate discovery into clinical application. Certainly, that's the larger mission of the NIH, is to support research. There are components of the government as well as components within the institute that would take this information in terms of education, outreach, and dissemination, and that would be very important for the community to do that. For example, one application is to disseminate the information we collected from a Tanzanian population in terms of craniofacial morphometrics, so that any reconstruction of the craniofacial region could follow a natural function and structure of African population, because that would be very different from the Caucasian population.
Yeah, thank you. So actually, we don't have enough time to talk about a lot of things today, but and actually we have one more lecture from Dr. Yamaza. I'd like to continue to the lectures first, and after that we will have the discussion between the audience and us. I'd like to introduce Dr. Yamaza, Haruyoshi Yamaza, Assistant Professor of the Section of Pediatric Dentistry, Kyushu University Faculty of Dental Science. he's so far working with the stem cell research that introduced by Kazu in earlier presentation, and I would like to present the future direction of the stem cell researches and also the possibility of the clinical application of the stem cells. Could you please start the presentation?
Good morning, everyone. So, thank you very much for introducing me, Dr. Takai. So, today I would like to talk about one of our research topic. Title is Stem Cell Research in Degenerative Density and the Future. So, as you know, stem cell research is one of the hot topics in Japan, United States, and other countries. So, stem cells have two major properties. One is self-renewal capacity, and the second one is multipotentiality. Stem cell under the special condition, so stem cell different into the several tissue or cells such as neuron, hepatocyte, and so on. And so stem cell is three kind of stem cell. So embryonic stem cell induced pluripotential stem cell and somatic stem cell. So embryonic stem cell we call ES cells is from the fertilized egg. Then this stem cell have a great property as a stem cell. But as you know, ES cell have some technical problem. Then it is difficult. Sometimes it is difficult to apply for the clinical application. So second one is we call iPS cell. iPS cell were established by Professor Yamanaka in Kyoto University. So iPS cell is an artificial stem cell, and this characteristic is similar to the ES cell. But this one is also some problem. So problem is this cell is safety for clinical application. Now it's not clear. Then the second stem cell is a somatic stem cell. So somatic stem cell is isolated from several tissue, including a bone marrow and adipose tissue, and also from the dental tissue. So in our field of the craniofacial region, so several kind of stem cells is isolated from the dental tissue, including dental pulp, papilla, and gingiva, and jawbone. So recently, new stem cell from the human exfoliated discharges teeth. So this stem cell isolated from the dental pulp tissue from the milk teeth. Then this milk teeth milk teeth is elucidate when permanent tissue is erupting. Then milk teeth discarded clinically and biologically. This milk teeth have some advantage for the stem cell isolation because we don't need surgical treatment to get the milk teeth, and so that it is very easy accessible and feasible source, we think. So stem cell have some stem cell share this share some property of the stem cell. For example, shed have a clonogenic potential and also have a good cell proliferation, like slide. And also shed express the surface marker of the stem cell. So shed belongs to the mesenchymal stem cell. Then shed express the mesenchymal stem cell marker of the CD147, CD73, and CD105. And also shed express the ESL marker of the like this. So somatic stem cell is including mesenchymal stem cell and other kind of the hepatic stem cell. Then shed doesn't express the hepatocyte hematopoietic stem cell marker CD34, CD45, and CD40. Then also shed have a multi-differentiation potential. Under the specific condition, shed induced into shed differentiated into the osteogenesis, chondrogenesis, and alipogenesis, like that. But so sometimes a shed have a stem cell property. Then so it's a very good cell source for the stem cell. But sometimes we for us it is difficult to isolate the stem cell from the milk teeth during the dental treatment. And also sometimes we don't know when we can get the exfoliated milk teeth because we cannot expect it. Then sometimes it is difficult to isolate the shed from the milk teeth immediately. So that we plan to do the experiment about the preservation of the dental pulp tissue from the milk teeth. Then we investigate the effect of the cryopreservation of the dental pulp tissue from milk teeth. So this slide shows the strategy of our experiment. So when we got the exfoliated milk teeth, then so we pick up the dental pulp tissue from milk teeth, then preserved this tissue in the liquid nitrogen for over 2 years. Then we isolate the shed from the preserved sample. Then we compare the preserved shed and the fresh isolated shed. Then this slide shows the cryopreserved shed keep the mesenchymal stem cell properties. So by the flow cytometric analysis, so this shed we call shed cryo. Shed cryo keep the mesenchymal stem cell marker such as STRO1, CD146, and CD20. Also, this shed cryo keep the chronogenicity like this, and so also this shed have a cell proliferation similar to the freshly isolated shed. And also we investigate the multipotentiality of the shed cryo. So in the special condition to induce the osteogenesis. Then so about the arizal staining, this means that this thing for the mineralization. So in the under that special condition or under the shed, so shed differentiate into the bone formation and also have a LP activity, alkali phosphatase activity related to the bone formation, and also differentiated shed it the osteoblast related gene including the LAMP2 alkali phosphatase and osteocalcin. And also in the under the inductive condition of the adipogenesis, also shed differentiated into the adipocyte, like so by stain, oillet or stain, so we can detect the lipid deposit, and also differentiated shed express the adipocyte specific gene of the LPL and PPR gamma 2. And also shed was differentiated into the neural cell and epithelial cell. So we confirm this differentiation by the immunofluorescence staining by the with the neurofilament M and tubulin beta 3. This molecule is specific for the neural cell. Also, differentiated shed placed CD31 and CD34 these molecules specific to the endothelial cell. So that cryo shed cryo-preserved shed keep the stem cell property. Then, so the property is similar to the fresh isolated shed. So next experiment, we investigate in vivo tissue degeneration and self-renewal assay. So we isolate the shed from the cryopreserved sample. Then, so we shed is transplantation into the immunocompromised mice with hydroxy appetite. Hydroxy appetite is the carrier of the shed. Then, so after 8 weeks later, after 8 weeks of the transplantation, transplant sample is harvested, then isolate the cell from the transplantation, then sorting the cell with the human CD146 antibody. Then, so we analyze the sorted cell. Then again we sorting the cell is transplanted into the immunocompromised mice. Then check the secondary transplantation sample. So that about the first transplantation sample, so you can see that dentin and dental pulp like formation is dental and dentin and dental pulp structure we can see in the transplantation sample, and also we can see the bone and bone marrow like structure in the transplantation sample, and also we can detect the human mitochondrial protein in the transplantation sample, and also we can detect the STRO1 and human CD147. These are stem cell marker in the transplantation sample, so that shed can be bone formation in the mice. Then also, then next we isolate the cell from the first primary transplantation. Then so sorting by the human CD146. Then so we confirm that these sorted cell by the flow cytometry, so that sorting cell keep the human CD146, and so but the negative signal for the mice CD146. Then also this sorted cell was transplanted again in the mice, so that transplantation sample show the dentin and dental pulp like structure and also these cells express the stem cell marker from the CD147 and also human specific mitochondrial protein. So that shed in the shed in the cryopreservation keep also have stem cell property of the renewal, self-renewal property. Also, shed can be produce the bone formation. Then, so next experiment, we generate the calvarial bone defect in the immunocompromised mouse like this. Then, so we then in the defect of the calvarial bone, we transplant the shed with the hydroxyapatite carrier. Then, so after 12 weeks, so we analyze the transplanted mice by the micro-CT and histology. So that this picture shows the calvarial area transplanted by the shed, fresh isolated shed and cryopreserved shed. Then, so you can see that transplantation of by shed, so bone formation can be successful compared with the transplantation only hydroxyapatite like this. Then also histological analysis. So transplantation of shed could be generate the amount of the bone marrow bone structure. Then, so around the bone structure, we can detect the human CD146 protein. This means that shed can produce the bone structure. Then also we detect the by trap stain. We can detect the positive signal, and this means that trap stain can be detected the osteoclast cell. Osteoclast cell is one of the one of the component of the bone. Then so that so shed can be could be the bone formation like to similar to the natural bone structure. Then in my present summary, so shed in the cryopreservation maintain the property of stem cells such as self-renewal and multipotentiality. Also, shed could induce the bone generation in the calvarial defect mice model, so that shed ideal source for the clinical banking of the stem cell, and also shed has great benefit in the regenerative medicine. So especially so bone graft into the cleft of cleft of upper jaw on patient of cleft lip palate. So in future, so we in future direction, so shape can differentiate into the several kind of the tissue. Today I show the bone formation, but so we believe that shape can differentiate into the another tissue, so including the epithelial cell, so that in future we can do we can treat the patient on the cleft lip palate totally by shape, including a bone defect and soft tissue defect. The last slide is our collaborator. So Dr. Takayoshi Yamada is oral anatomy at Kyushu University, and Dr. Amaran is our graduate student in the federal university, and also Kazu Nonaka in here, so is our host in the federal university. Thank you very much for your attention.
Thank you very much presentation. And actually, the now we have time to question and answer discussion. Does anyone have a question or comment to our lectures or the discussions? Please.
A question to Professor Zanaka. You talked about environmental interferences on the craniofacial abnormalities. Would you like to elaborate a little bit more on that? You're seeing very different kind of incidence rates around the world.
Yeah. Thank you very much. It's a very important question. Also, one person can do just limited experiment, so we need to expand our possibility through the international collaboration to examine the environmental effect, like environmental disturbance agent, which might be involved in the craniofacial anomaly, including the cleft lip and palate. Actually, in Japan, our government launched some 2 years ago. Our government launched some specific program to examine the effect of the environmental effect on the newborn baby for 12 years from now. That's in Japan, but also internationally, collaboration is essential to expand, to understand the exact phenomenon and the mechanism. That's my answer. Thank you very much.
The second issue is related to the current agreement between the NIH and the European Commission on research activities and adaptation. Do you have any experience of joint work between the NIH and the European member states within the framework program for research? And secondly, do you participate to some extent in the definition of the new Horizon 2020 context for the European Union?
So to answer your first question, we have supported projects in the European nations. Some of the projects utilize specific population because of genetic as well as environmental factors. Some investigators have unique expertise and instrumentation that's not available in the United States, and they develop a project that NIH will support. And then many more projects are actually collaborations between European investigators with United States investigators. And so, in a way, even in the face-based consortium and the hub project, Dr. Murray actually had a collaboration, a small collaboration out there at this point with the United Kingdom, and they contribute some imaging data to our data collection. As far as the second question, at this point, I'm not aware that we're part of that Horizon 2020 effort.
Okay. Any other questions, comments? So this, I think this kind of the issue is very new for you and maybe a little bit hard to understand. But we would like to answer to any kind of the basic questions or something like that, because you know the presentation done by the especially like from the Dr. Yamaza is very you know basic and maybe maybe you have a lot of basic questions to what his books. If maybe the wording or like the stem cells or the any kind. If you have any question, that we would like to welcome that kind of questions. Do you have any? Please.
Yeah, I saw that the very first slide, the rate of cleft lip palate in Japan seems to be very high compared to the US and the other countries.
Mm-hmm.
Is there some genetic background or some environmental issue?
Thank you for your question. It is very good question, but difficult to answer. You know, even in Japan, incident rate of the cleft lip palate is different. In northeast Japan, we have a 1 out of 500 incidents there around the Sendai or the Tohoku area. But in southwest part, like Kyushu, we have about 1 out of 600 to 700. So maybe some environmental factors are affecting to the incident rate, but also the because genetic background can be solved, because you know Japanese racial difference of Japanese population is also exists between the northeast part of Japan and southwest part of Japan, because you know northeast Japanese people in the northeast part come from the north, right? And actually the in very beginning of the Japanese history, but and the southwest Japanese people is coming from the Asia or Southeast Asia, so maybe some genetic difference will be exist, but we don't have the exact data so far. Do you have any comments or?
I answer a similar question to the previous question. I explained the Japanese government really want to know the gene effect and environmental effect on the occurrence of the cleft lip and palate in the newborn baby. So that's the reason why government runs the new research project. We call it the ecology effect on children. We call it ECO. So later on, I think 10 years later or 20 years later, data will be collected in the Japanese white people.
But you have,
Please.
do you have any kind of evidence, for instance, or of the influence of maternal, or the increased average maternal gestational age on the final product. May I confirm it? We share the aging population.
Question is maternal age, whether or not maternal age is involved in the occurrence of the epileptic band palate in the newborn baby. How can I say it's not so easy? I don't have any data. But as you know, Down syndrome, exactly, yeah, yes. Regarding for the epileptic band palate, we don't have any clear answer.
Yes, actually, some data. The father is over 40 years of age, or something like that may affect the incident rates, but actually we don't have complete evidence that age is relating to the incident rate of the reproduction palate. Do you have any comment?
No, but I have a question for the
Please.
So you show that the shed cells are very powerful tools for tissue regeneration because they can regenerate bone and skin and other pathways. Is there a preferred phenotype, a preferred pathway that these cells would generally take if you do not put them into induction medium? Do they prefer to be bone, or do they prefer to be cartilage? Is there a larger proportion of one type over the other in terms of outcome?
So usually, shed we can see the stem cell. And so in the specific condition, so we can divide it into the bone structure and sometimes and so.
So you have to grow them in specific conditions for them to differentiate. They have not a preference.
So shed can be proliferated by passively. But also there is a passively, so our shed reduce the power and the stem cell, so that we have to keep the fresh isolated shed for the future, for the against some disease.
Any more questions or comments? So mostly the time is run out. Actually, I'd like to close this session. Thank you very much for attending this meeting this morning. I appreciate all of the audience here today. Our project is just started, and actually, very, I think, unique in this USJI. So we'd like to continue seeking opportunity to talk about all of you here in the future. And actually, we are looking for actually. I'd like to welcome the comments or the questions to us even after this seminar. Thank you very much for attending today. Thank you very much.